Welcome to This Explainer. Today, we're stepping into a massive, real-world data science mission. We are literally laying the groundwork for a complete risk intelligence system for NorthBridge Bank. So we're moving way beyond textbook theories here to see exactly how professionals detect and prevent financial fraud using data.
Here is our roadmap for today. First, welcome to NorthBridge Bank. Second, inside the transaction data set. Third, tackling imbalanced data. Fourth, the end-to-end workflow. And finally, prerequisites for success.
Okay, let's dive into this first section. Welcome to NorthBridge Bank, building a risk intelligence system.
Listen, banks lose billions to fraud every single year, so bridging the gap between machine learning and tangible business value is absolutely critical. If you're an aspiring data scientist, a transitioning data analyst, an AI engineer, or a student looking to build a rock-solid, industry-ready portfolio, this is for you. We're building skills here that directly translate to the modern tech and finance workforce.
Moving right along to Section 2, inside the transaction dataset, the raw materials.
Any system is really only as good as the raw materials you feed into it. And for this, we are working with 1,296,675 real-world inspired credit card transactions. Yeah, let that sink in. This isn't some tiny toy data set with a few hundred rows. It's at this massive scale that the real hidden patterns emerge, and where you truly learn how to optimize your code, understand complex data distributions, and train robust machine learning models.
And these 1.29 million transactions, they weren't just captured in a single afternoon. This data actually spans 51 U.S. states over an 18-month period, stretching from January 2019 all the way to June 2020. We're tracking a living, breathing financial ecosystem here, complete with regional nuances, seasonal spending habits, and shifting consumer behavior over time.
Inside every single one of those million-plus rows are vital puzzle pieces. We've got customer demographics and merchant details to understand exactly who is buying from whom. We have transaction amounts, exact timestamps, and geographic locations. And crucially, we also have fraud labels. That's the historical record of legitimate versus criminal activity. Our job is to figure out exactly how all these variables interact to predict that final label.
Now for Section 3, tackling imbalanced data, finding the needle in the haystack. If this project has a villain, this is definitely it. And this brilliantly illustrates the problem. 99.1% of our data consists of legitimate, everyday transactions, groceries, gas, streaming services. Only a microscopic sliver, 0.9%, represents fraudulent transactions. We are quite literally looking for a needle in a massive financial haystack. That rarity is going to force us to elevate our data science techniques way beyond the basics. Which brings us to the definition of imbalanced data. Simply put, it's a data set where the classes are not represented equally. Why does this matter? Well, think about it. If I built a completely useless machine learning model that just blindly guessed not fraud every single time, it would boast a 99.1% accuracy, but it would fail entirely at catching actual criminals. Because of this, standard accuracy metrics just go right out the window, and we have to deploy specialized, industry-standard techniques designed specifically for these environments.
That brings us to Section 4, the end-to-end workflow, the blueprint.
Let's move to and see how this builds across our methodology. To transform this raw, imbalanced data into a sleek, risk-intelligent solution, we follow a systematic workflow across 4 main phases. First, explore and clean, to ensure reliability. Second, statistical testing, to mathematically validate our assumptions. Third, predictive modeling, to actually detect the fraud. And finally, step 4, evaluate financial impact, where we calculate exactly how much money our model will save the bank. Expanding on that blueprint, here is your path to becoming a full-stack problem solver. You'll confidently load and explore large data sets, clean and prepare the data, and perform deep exploratory data analysis. Then, you'll lock down your findings with strict statistical hypothesis testing. From there, you'll build and compare multiple ML models, completely bypassing the pitfalls of imbalanced data we just talked about. Finally, the whole shebang culminates in creating a production-ready scoring pipeline that estimates real-world business value.
All right, final section, Section 5, prerequisites for success, required gear. Before we write our first lines of code, here's exactly what you need in your Expedition pack. You'll need Python installed on your machine, an environment like Jupyter Notebook or VS Code, and foundational knowledge of Python and Pandas. But honestly, the most important thing you need to bring is curiosity and a willingness to learn.
This project is going to challenge you, for sure, but if you lean in, you'll come out the other side with incredibly valuable, highly hireable skills.
Which brings us to the ultimate question. Are you ready to find the 1% that matters? That tiny fraction of fraudulent data holds the key to saving NorthBridge Bank millions. Today, we've outlined the high stakes, explored our massive data set, identified our imbalanced data villain, and mapped our blueprint for success. So make sure your environment is all set up, because next time, we're diving straight into the code. I can't wait to see you there.